Hey guys, Mr. Gran here. This is 13.4 inverse trig functions. And in this video, we are going to be using the unit circle to evaluate the inverses of trig functions. So there's some basic steps we can take, just some ideas with this. It's really just using the unit circle backwards, right? So we are finding angles which have specific trig ratios. It's basically using the unit circle backwards. So instead of finding an angle and then its x and y value, or x or y value is the answer, now we're finding the x or y value and the angle will be the answer. So we'll find the trig ratio on the outside of the unit circle and the answer is the angle on the inside. And usually there's going to be two answers for this. All right, so for our first one, the wording of this is important. It says find exact values between 0 and 360 degrees. We have two methods for measuring angles on the unit circle, degrees and radians, and this tells me that my answer should be in degrees. All right, we want to know cosine inverse of root 3 over 2. Now cosine goes with the x value, so I am basically looking for where is x equal to root 3 over 2. Where is that true? So looking at the x values, I've got a positive root 3 over 2 over here and a positive root 3 over 2 down in the lower right. So right here and right here. So my two answers for this are 30 degrees and 330 degrees. All right, so now answering in radians. This one is saying find all exact values between 0 and 2 pi for inverse sine of -1/2. So now, because it's saying 0 to 2 pi, that's telling me I need to answer in radians rather than in degrees. All right, now sine is the y value. And so essentially what I'm doing is answering where is y equal to -1/2 on the unit circle. So the y values are -1/2 at these two locations, right here at 7 pi over 6, and over here at 11 pi over 6. So 7 pi over 6 and 11 pi over 6 are my two answers. All right, we can do the same thing for tangent. We're doing all exact values. We're in degrees now again. Tangent. Remember, tangent is the y over x, which is that number we added to the outside of our unit circles. And mine doesn't have it again, so I'm just going to have to go off of memory. So where is tangent equal to, where is tangent of theta equal to root 3 over 3? Where is that number on the outside equal to that? That would be down here. I wonder if I can fit it on here. Root 3 over 3, I can get it really tiny on the very edge right here at 30 degrees. And then it should be also root 3 over here, positive root 3 over 3 at 210 degrees. So 30 and 210. All right, so this one's kind of a trick question. We're in radians, right, because it's 0 to 2 pi, and we want to know where cosine inverse of 3. Cosine is the x value, so I want to know where is x equal to 3. Well, the maximum value for cosine, or sine is 1. That's the biggest x value. So 3 would be like way off the graph outside of the unit circle. So when this happens where it's not a value that's on this circle, right, that means that this is undefined. And you could get this by plugging this into your calculator. If you do inverse cosine of 3, it's going to give you an error message. That means that it's undefined. All right, so a little bit of mixed review. If you want to pause and try these out. The cosine one, right? Cosine is the x value, so where is x equal to -1/2? That is going to be over on the left half, and that will be here at 120 degrees and here at 240 degrees. So those are my two answers there, 120 and 240. tangent of 1. Where is that number on the outside equal to 1? Mine doesn't have it, but luckily I remember. It is 1 here at 45 degrees, and it is also a positive 1 here at 225 degrees. So 45 and 225. All right, sine inverse of root 2 over 2, we are looking for where is the y value equal to root 2 over 2. And so we're looking in the top half, because that's where y is positive, right here at 45 degrees, and here at 135 degrees. And then inverse sine of 0, again, we're looking for the y value, where is y equal to 0? And that is going to be right here at 0, and then over here at 180. So 0 degrees and 180. All right, last example, same thing, except now it's in radians, right? And I can tell because it says find all values between 0 and 2 pi. But it's the same idea. Where is y equal to 1/2 for sine of negative 1/2? That's down here and over here. So at 7 pi over 6 and then 11 pi over 6. So 7 pi over 6, 11 pi over 6. This is an interesting one because inverse tangent of undefined. What a lot of students will do, and they're not quite wrong in thinking this, it's not bad logic, but tangent is undefined at 90 degrees or pi over 2, and also at 270 degrees or 3 pi over 2. So they would answer this as pi over 2 and 3 pi over 2. However, undefined is just undefined. You can't use undefined as a value inside of an equation like this, right? Undefined is not a numerical value, so you can't really plug it in. So even though it makes sense to think tangent is undefined here, so inverse tangent of undefined is this, we can't define what undefined is, and you have to have a definable value inside of here because this could really be anything. So this, by definition, is also undefined. Again, because it doesn't make sense to plug in undefined into here. It would be like saying, what is inverse tangent of orange, right? It just doesn't make sense. All right, next one. Cosine inverse of 1, so where is the x value equal to 1? This is a good one because there is only one answer to this. Cosine equals 1 right here. It is the maximum value, and so there is only one of them, and that is at 0. And then sine, that is again the y value, so where is the y value equal to root 3 over 2? That would be at these 2 points. That's 60, not 60, we're into radians, pi over 3 and 2 pi over 3.